0, decrement X, and then semicolon, and that's it. There's still an else branch there, which is do nothing to X or anything else. So be careful of assuming, well, if I test statement coverage, branch coverage, it's all the same thing. No, statement coverage does not imply branch coverage, but branch coverage does imply statement coverage. Payush asked an interesting question here. How can we map or measure the code to the requirements coverage? These are really two different things, Payush, that are not, they're complementary. So if we're talking about the requirements, and here I'm assuming we're talking about requirements that specify the desired behavior of the system, then that's black box testing, right? That's testing based on requirements. Now, the code coverage is white box. Now, the fact that there's not necessarily a mapping from those two things, from the requirements down to the code, is not necessarily a problem. Now, in some industries, it is a requirement that you do that you have traceability down from the requirements to the code. Certain regulated industries have that as a requirement. But from a tester's point of view, a professional tester's point of view, really what you want to do is say, well, I want to come at the testing problem from multiple angles. So there's a certain kinds of bugs that static techniques like reviews and static analysis are good at finding, so we apply those. And then there are certain kinds of bugs that the different white box techniques are good at finding, so we apply those techniques and find those bugs. And then there's other kinds of bugs that the black box techniques are good at finding, like equivalence partitioning and state-based tests and exploratory testing and so forth. So we can apply those techniques. Basically, the idea is that as you proceed throughout the software development lifecycle, you're applying a set of appropriate bug filters at each stage of the lifecycle, and that's achieving the desired effect of ultimately filtering out most of the bugs. And this is a fairly easy exercise if you just think of, if I have 100 bugs and I do static testing and it finds half of the bugs, and then I do white box testing and it finds half of the bugs, and then I do black box testing and it finds half of the bugs, how many bugs are left at the end? Well, 500, 250, 125, right? Because half of 1,000 is, or excuse me, 100 is 50, 25, and then 13. So you get out 87% of the bugs, even though you're only 50% effective at any one of the phases. And so that sequencing of testing is really what you're trying to accomplish here. And so don't worry too much about establishing relationships between requirements coverage and code coverage. What's more important is applying the appropriate filters at each stage. Let's see, Shmuel, good, thank you. Shmuel mentions Visual Studio does a psychrometric complexity analysis too, so that's helpful to know. Thank you, Shmuel. Tim, thanks. Another pointer from Tim. Requirements catalog PDF, www.exemplar, example with an R at the end, .com/testing-com/writings/catalog.pdf. So exemplar.com/testing-com/writings/catalog.pdf. Andrew Kalpak says LDRA testbed claims to have data flow coverage. I haven't used it myself, but it might be interesting. Okay, thank you for that, Andrew. It's interesting to have heard that. I'll make a note to take a look at that at some point. Yeah, it's hard to say much about them if you haven't used them, and I haven't used that tool myself. So it is interesting to know that there is at least something out there that is apparently able to do that, and I think that's really the only way, as a practical matter, to do that data flow analysis. I really don't think that you'd be able to do it by hand. I mean, I guess theoretically you could, but it's tedious beyond belief and very error prone. I mean, the times that I've done it to try to create examples, for example, for this presentation, I made a lot of mistakes that I had to scrub out. So I think that it's not very helpful when you're not really able to apply the test technique itself without making a bunch of mistakes at it. And it's certainly not something that is any fun, and like you'd want to get good at doing it through a lot of practice. Andrew also provided the link for that. It's www.ldra.com/dynamicanalysis.asp. So take a look at that if you're interested in data flow. Oh, here's an interesting question from Tim. We had trouble with testing Firefox where we have runtime generated JavaScript code. Any tips on handling coverage of runtime generated code? Wow, that is a fascinating problem. I have not had to do that myself. Every time I've used code coverage for my own projects or with a client, I've been working with code that was not a moving target, basically. It wasn't generated at runtime. It was code that had been written and was sitting there in files. So I'm not familiar with any of the tools being able to do that. I would assume that's something you'd want to, if that's something that you need to do, then you could check for the tools. Now, another alternative would be if you can control the way that the runtime generator generates code. In other words, you control the thing that's producing the JavaScript. Perhaps you could add a switch to it that would build in the probes necessary to do the coverage analysis yourself, because at least for statement and branch coverage, the probe is a pretty simple thing. All it needs to do is every time it enters a function and leaves a function, it makes an entry in a table that says, I got here, and here is defined as some sort of sequential stamp or something that uniquely identifies where that probe is. And then every time you get to a branch, you put a probe on both the true and the false side of the branch, and also same with the looping and with the switch case constructs. Anytime that the control can flow in different ways, you put a probe in there, and the probe just basically makes an entry in a table somewhere. It says, I got here, where here is, as I said, defined uniquely with some sort of unique, perhaps a sequential identifier or something like that. I haven't tried it, but I would think that would be something that would work. And again, it would at least allow you to be able to determine statement and branch coverage. You start getting into condition coverage and multi-condition coverage and that sort of stuff. I think that's going to get more complicated. But, this is the old 80-20 rule that something very simple can get you 80% of your benefit, and maybe that's enough. Let's see. A question from Tom here. You haven't talked much about the psychological side here, how real development teams react to code coverage metrics. It doesn't take much research to show, and people have done it, that code coverage targets will often lead test teams to do whatever they can do to reach the targets, and then any coverage metric will sit there right above the target, not the best for full coverage or for the best code. What can you say about that from your experience? Tom, that is a great point. And this is really, metrics in general, right? Anytime you adopt a metric, you start measuring something, people change their behavior to try to achieve something that they would consider goodness with that metric. You can try to deal with that by making sure that there are not individual rewards or punishments tied to those metrics, but that's again, the very fact that people know that you're measuring something, it will modify their behavior. It's important that you not just have one set of metrics, right? I mean, basically what we've got here with code coverage is a tactical metric that allows us to measure at the